In this video, I'm going to show you the minimum height of a mirror needed for a man to see his full height. So in the illustration here, to keep ray diagrams as simple as I can, we are going to assume that the eye of the man resides at the top of his head. And we're going to assume that this long line represents the height of the man, and his eye is literally at the top of his head, just to keep the diagram simple to illustrate the point. So over here we have a man and a mirror. As you can see, the mirror is not the full height, but the question is, what is the minimum height needed for the man to be able to see his full height in the mirror? Now, first step, we need to locate the image of the man in the mirror. So in this illustration, what I have is a digital ruler, but it doesn't have any scale on it. I'm just going to count the intervals, the long intervals, right, to mark out the position of the image of the man. So the man himself is about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's about 10 intervals away from the mirror. So I'm going to count the same in the other direction to determine the location of the image of the man. That'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So he'll be here. I'll just change the ink to an orange one, just to distinguish between the image and the man. Right, now we need to draw the height of the man. Now bear in mind, this is a mirror image. So we need to represent him with dotted lines. So what I have here is the image of the man. Now, first things first. First things first, we draw how he sees his own eyes. So, assuming that's the eye over there. Okay. The light rays strike the mirror and reflects back. Right, I need to draw the dotted line to illustrate these are equal length. So the light ray strikes the mirror and reflects back into his eyes. So that's how he sees his eyes. Sorry, that's how he sees the image of his eye. and the image of his eye is how he perceives where it is to be in the mirror. So next we need to locate the rays that shows how he perceives where the image of his foot is. Right, so this is where he perceives the image of his foot. Okay, so mind you, we're going to draw the ray from his eyes. Sorry, should I say from the mirror to his eyes? So this light ray exists, but behind the mirror, things do not exist. They are virtual in nature. So we represent the rays in dotted lines. And that's how he perceives the image of his foot. And how does the ray from the mirror goes to his eyes? It has to come from somewhere, right? So it has to come from his foot, the original foot. So in this case, the light ray from his foot strikes the mirror and then reflects off the mirror into his eyes. So that means the direction of the light ray has to be from his foot towards the mirror and from the mirror to the eyes. If you look at this diagram carefully, you realize that if the height of the man is h, the height of the mirror is actually half h. And I just have to erase out this part. And this part. Okay, if you are watching this on your handphone or you're watching this on your tablet, you may take a ruler to measure the height. So the height of the man is about, sorry, it's not about, the height of the man is actually twice the size, the height of the mirror. Or the height of the mirror is half the height of the man. Now when you draw ray diagrams as such, just do not leave the diagrams as it is. We always need to verify our answers. We need to verify the accuracy of our drawing. Now, we need to bear in mind that I'm drawing this on the tablet, so the drawing may not be that accurate, but I still need to make some measurements to make sure that my drawing is as accurate as it can be. So for a start, I have to locate the point at which the incident ray and the reflected ray meets, and I need to draw a normal. Now the reason for drawing the normal is I need to find my angle of incidence and my angle of reflection. If they are equal, most probably there's a very high chance that my diagram is quite accurate. So I'll just change this to protractor. I'll shrink it by a little bit. And I'll just draw the angle. from the normal to the incident ray, as you can see, is about 29 degrees, about 30 degrees. How about I enlarge it and I draw another angle? It's about 29 degrees. So my angle of incidence is about 29 to 30 degrees. My angle of reflection is about 29 to 30 degrees. So in this case, I will say that this diagram is relatively accurate despite being drawn on the tablet. And yes, here is your proof. And here's your proof on you only require the mirror to be half the height of the man for the man to see his full image. So in other words, when you are at home, you don't really need a full body mirror. All you need is a half mirror for you to see your full reflection.